Okay, again, good morning. This is Geometry Lesson 4.2 on reflections. And so what are you going to be able to do? You're going to be able to graph the image of a geometric figure after a reflection across the reflection of the image across a line of symmetry. And I'm going to add this to it. I will be able to find the coordinates of the vertices of the reflected image or the reflected pre-image. Remember, we have an image and a pre-image. The pre-image is what you start with, that's your starting point, and then you reflect and you end up with the image. Okay? So this lesson supports these IXL skills, L8 and L9, which are on the two topics that I just mentioned there. And remember that you're going to upload your notes to me. This is the protocol for putting in your header. Make sure you do it as I've shown it. If you send it to me, if you send your notes to me by email, make sure that this information is in your email header as well as on your lesson notes. If you just upload the lesson notes by the Student View Dropbox, you only need to put the header material on the notes themselves. Okay, and this must be done by 11:59 p.m. Saturday. Okay. All right, so let's take a look at this. Most of this is very visual, so the screens will go fairly quickly. So the first one here, first example, is what is the image of triangle DEF after reflection across the y-axis? So I've got this graph here, and you'll notice you see this triangle DEF, and we're going to reflect it across the y-axis, which is the vertical axis. So when they say reflect across the y-axis, that means it has to go to the other side of the y-axis, over here. And so you have to remember that this XY coordinate chart is divided into 4 quadrants. Here's quadrant 1, where your X and Y coordinates are all positive. Over here where the triangle DEF is located, this is quadrant 2. Here, all of the X coordinates are negative on the x-axis, and the Y coordinates continue to be positive. And then down here, this is quadrant 3. Quadrant 3 is down here, and you'll notice that the X and the Y coordinates should all be negative. And then over here in the 4th quadrant, you'll notice that the X coordinates are positive and the Y coordinates are negative. So I always put this on when I'm doing reflections or rotations for that matter, or any translation or transformation, because I'm moving these figures around, and if I move them to a different quadrant, I got to know, where it's going to, and I got to know how is it going to change the character of the coordinates. So one of the changes is the sign goes from positive to negative. And so also, because this is a reflection, the image will be a mirror image, and it will appear that the pre-image has been flipped over like a pancake. Okay, so we're going to see this image over here, but when we sketch it out, it's going to D is going to be over here on the far right, not on the far left. Okay, so that's going to give you an idea of what you're doing. All right. So as I said, a reflection flips a figure across a line to create a mirror image. When a point is reflected across the y-axis, the coordinate changes sign. So that's what I said. So in any of these coordinates where that had negative x coordinates, they become positive x coordinates, and the y coordinates remain positive because both quadrants have positive y coordinates. So we're going to reflect the point D, which is negative 6, 2. That's the first point. That's the coordinates for D here. So they just took D, put it here, gave you the coordinates. It's negative 6, 2. And since D is 6 units to the left of the y-axis, D prime, which is going to be the image point, is 6 units to the right, because you've got this pancake flipping thing going, okay? So you'll notice Y here, the y-axis, that's the line of reflection, sometimes called a line of symmetry. And it makes the 2 points even across that line. They're symmetrical. So over here, what is that going to make this point? So you've got to think about that. What would the coordinates be? And so, you know, all right, if quadrant 1, the x and y coordinates are positive and positive, then that means that this x coordinate has to be positive as well. So D prime should be x is positive 6, y is 2, whereas D was x is negative 6, y is 2. Okay? All right, pretty simple. All right, now you're going to reflect point E. So point E, you know, when we first looked at it, those two were only a unit apart. So, you know, here's point E, it's just a unit apart. So it's at negative 5, 2. And so since E is 5 units to the left of the y-axis, then E prime for the image has to be 5 units to the right. So here it is showing as you see it there. And so since E's the pre-image, E, since its coordinates were negative 5, comma 2, then E primes have to be positive 5, 2. E's negative 5, 2. E prime is positive 5, 2. Okay? All right. And so then lastly, you're going to do F. So now they show the whole triangle for you because you pretty much have got the whole picture. So F's up here, and it's at negative 4, 9. Okay? So again, you're going to reflect it. And so F prime, let's just say F here. F is 4 units to the left of the y-axis, so F prime's got to be 4 units to the right. And so its coordinates for that image point are positive 4 and 9. Okay? So now you've got the coordinates that you needed for this, and you were able to graph these. Okay? Now, you know, I gave you these coordinates, but I'm going to, in a moment, we're going to actually kind of go over, in fact, and the next problem we're going to go over just concentrating on the points themselves. We want to be able to make sure we understand, again, the switching around that I just did. So for this part of IXL, which covers, I think it is, what's it, L5? No, L8. L8, this is all you would be doing. You would be setting up a reflected triangle in the right spots, not necessarily having to come up with the coordinates, but I did it because you really need to see that to understand what it is you're doing. Now, second example covers, what is it? I think it's L9, yeah. So in L9, we cover what we're doing here in example 2. So it just says, what are the coordinates of the vertices of this triangle, PQR, after reflection across the x-axis? So, you know, be careful, make sure you're following these directions. So this is talking about reflection across the x-axis, not the y-axis. So if this is the x-axis, the horizontal axis, that means that the triangle has to be reflected up into the quadrant here. Remember, this is quadrant 1. Over here on the right, this is quadrant 2. And down here where the triangle is quadrant 3. And then over here, this is quadrant 4. So the triangle is going to be reflected across the x-axis. So it's going to go from quadrant 3 to quadrant 2. And again, just to help ourselves, quadrant 1, both x and y are positive. Quadrant 2, x is negative and y is positive. Quadrant 3, both x and y are negative. And quadrant 4, x and y are, well, x is going to be positive and y is going to be negative. If you do that every time, you're always going to be able to do this pretty easily. Okay, so we want to know what the coordinates are of the vertices, but first we know we're going up to quadrant 2, and so in this particular quadrant, quadrant 1, where the pre-image of triangle PQR is, you can see that your x and y coordinates for all three of these vertices, P, Q, and R, have to be negative. X and y will both be negative, okay? All right, so reflection again flips a figure across a line to create a mirror image. And so this has been highlighted for you so you can see that this is your line of reflection. It did something that the previous example did not do. But it's nice, you can see then that if you're going to start with point P, which is what they start with, they want you to reflect point P. So when a point is reflected across the x-axis, the y-coordinate changes sign, just like we said. X and y, this is quadrant 2, right? X and y, x is negative, y is positive. Down here, quadrant 3, x and y are both negative. Quadrant 1, we'll just do this. X and y are positive, and quadrant 4, x is positive, y is negative. Okay, so we know we're going from where both coordinates are negative to where the x is negative and the y is positive. So they give you the point. They would do it for you, but if you have to, you can count. So x would be 1, -1, -2, -3, -4, -5. So x is -5, and P's y-coordinate going down is -1. Those are the x and y coordinates of the original pre-image point. The image point up here, x is still going to be negative, right? So that's going to stay -5, but you're above the x-axis now where y is 1, +1. Okay, so that's the new coordinates for the image. So there you go. And so now we're going to do point Q. So again, looking at your original triangle, you remember point Q is over here, and so it's where x is 1, -1, -2, -3, y is -1. So they tell you that. Now reflect point Q at which is at -3, -1 for the pre-image. Okay, that's this one here, across the x-axis. And again, when you reflect across, you're going the same distance from the the x-axis that Q was. So Q is 1 unit from the x-axis. Q prime is 1 unit from the x-axis. So it's a reflection. It's symmetrical. And of course, again, when you look at this, x is still going to be -3, but y is now +1. Okay. All right. So that's easy. So now you're going to do the third one. And as in before, they give you the points coordinates for R. So R up here, well, R down here, the original R, its coordinates going down. X is, let's see here. Here's where x is. So -1, -2, 1, -2, -3, -4, -5, -6. So this is -6. Now I'm purposely counting myself, even though it's up here. So its x is -6, and its y is going to be -10. That's easy because it shows you right there. So -6, -10. So when I move it across here, what happens? The y has to change to +10. So this is x is -6, y is +10. That's the image's reflected point r prime. Okay, so now that you've got that, this is what they're going to give you. They're going to give you something that looks like this. And so this is what you commonly see when you're being asked to do some kind of rigid transformation. So this is called arrow notation. And you'll notice it's because there's these little arrows. So you say point P. The way this would originally look like is it'd be point P, and then there's its coordinates, -5, -1, and it's taking you over here to point P prime, and that you have to fill in yourself. So point P, we said was -5, -1, so going up to here, point P is -5, +1. And so there it is. Okay, so you've got to do that mental math there, or you need to go back, make sure you've got your coordinates showing for each of the points on the graph itself. Draw these graphs, okay? All right, so here's point Q. Point Q was originally at -3 and 1. X is -3, y is 1. And it's, I said it wrong, -3, -1. And Q prime across the x-axis there, the y is now positive, so Q prime is -3, +1. So you would write this out, and you would put Q prime. I'll just do this part of it. Q prime. And you make sure you show the prime, little prime tick mark there. And we said -3, +1, because we are in quadrant 2, where the x and coordinates are x is negative, y is positive. Okay, very important. Okay, the last one, same thing. R down here in the third quadrant, pardon me. It is third quarter though. X is negative and y is negative, and so we had R's down here, -6, -10, so that means R prime has to be x is -6, but y is +10, which is exactly what we got up here. Okay, so that's how you do the second IXL if you haven't done it yet. Go through, make sure you very carefully do these, but in your notes, make sure you're carefully drawing these. You can sketch these graphs, that's fine. But do your make sure you do a fairly legible grid and count things out so that you can determine that yes, indeed, you're being accurate about it. But at the very minimum, even if this wasn't even if you didn't have this nicely done graph for yourself, if you see that all the coordinates of your pre-image are negative, you can at least sketch the x and y axis, sketch the quadrants, put in the positive, negative values for x and y. Say, oh, okay, we're in quadrant 3, and they will always tell you which axis or which line you're going to go across. Now, when you get into the more sophisticated stuff, you will not be going across an x or y axis. You may be going across any line along here, but they will direct you. They will tell you what line it should go across, and the rules are essentially the same for all of this stuff that we're talking about. So you should be able to do it without any trouble. Okay, we are done. I'm going to let you go. I'm going to stop the recording now.